This is a simplified version of a Twitter or X database with users, tweets, likes, replies, and most people design it wrong. X handles millions of posts every day, and a big part of it comes down to how these tables relate to each other. I'll walk you through this ERD step by step so you can see exactly how a system like Twitter or X actually fits together. And if you want a clean copy of this diagram to study later, I've linked a free database design project guide below. Before we start designing, we need to be clear on what the system needs to support. For our simplified version of Twitter, here are the core features we want to capture in our database. Users can sign up with a username and email and update their profile. Users can write tweets, which are short text posts. Tweets can be replies to other tweets. Tweets can include attachments like images or videos. Users can follow other users. Users can like tweets, and users can retweet tweets. We're not covering things like hashtags, quote tweets, notifications, or direct messages in this version. It's just the core posting and interaction features. Let's start with the most important table, the user table. This table stores each registered user. We have an ID as the primary key, which we have for most of our tables in this design. It's a big int, which allows us to store a large number of values. We have a username and an optional display name, along with profile details like bio, location, and website. We've also added timestamps for when the user was created and last updated. This user can write tweets, follow other users, like tweets, and retweet, and we'll link to all of that in our design. Next is the tweet table, which stores every post made by a user. Each tweet has a user ID which links to the user who wrote it. The content is a short text message. We're not specifying the length in the database here, but you can do that in your design. Historically, Twitter only allowed 140 characters, then expanded to 280, and now I believe it's in the thousands. We've also added in reply to ID, which allows tweets to be replies to other tweets. This lets us model threaded conversations. Let's look at how we handle followers. This is a classic many-to-many relationship between users. We have both a follower ID and a followed ID. This captures both users involved in the relationship. Each row in this table means user A is following user B. You can easily query who a user follows or who follows them using this table. It also allows for both one-way and two-way follows, because Twitter or X allows a user to follow someone without that person following them back. Next is the tweet like table. This table links users to tweets that they like. Once again, it's a many-to-many relationship. One user can like many tweets, and a tweet can be liked by many users. We just store these IDs. We don't have a separate primary key for this table. If you want to show how many likes a tweet has, you can just count the rows in this table for the tweet. This could be a performance concern as your database grows in size. If it becomes an issue, there are ways you can improve it, such as storing an approximate value in the tweet table, which is refreshed every so often. A retweet is when a user shares someone else's tweet. Retweets are stored in their own table. This lets us capture when a user reshared a tweet. This captures the user ID who makes the retweet, the original tweet ID, and a date. Alternatively, you could model this by adding another column to the tweet table, which may even be a better way to do it. However, keeping retweets in their own table may give us more flexibility, especially if retweets behave differently or are tracked separately. Tweets can also include attachments like images or video. This table stores information about any media attached to a tweet. Each attachment is linked to a tweet using this tweet ID column. If a tweet has no media, it won't have any rows here. We have the file location, which would refer to a URL or somewhere on a file server. We wouldn't store the actual file inside the database column. We have the file size in case it is needed for validation or for display. You could expand this by storing thumbnail sizes, durations for videos, or even external links. Of course, this is a simplified design. Twitter at scale needs much more, such as partitioning tweets by time or user, indexing for faster queries, and caching. But this ERD gives us the relational foundation. If you'd like a copy of this ERD that you can study or adapt for your own projects, download the free Database Design Project Guide. You'll find the link in the description. This was a simple design compared to many others that I do. To apply this process to any database design, you'll want to watch this video next, where you can learn the process to go from requirements to database design in any domain. Thanks for watching.